evening.
You've got everything you need about Hack Night?
Yeah, well, I might call you out and you can stand up and say hi. But yeah, I've written Hack Night, new agenda, everything about 9 times between blog posts and meetup and this. So yeah, but I'll call you out and say, hey, you're Luke's in charge.
I don't know if I'm in charge.
Well, as in you spearheaded it.
Well, it was just no one did anything, so I thought I'll just do it and we'll get it going. So.
That's how everything works. Sponsors are looking good.
Okay, cool.
So we could have $4,000 for it for the year.
I don't know what we're going to spend it on.
No, but it should be enough to.
Yeah.
All right, let's get going. Good evening. Welcome to our new tight schedule evening, and welcome to 2018. We'll get there. I purposely didn't set up the chairs near the pizza, so grab some extra chairs and fill them in as we sit down. There's also more chairs available as well, so people don't need to stand up necessarily. Did everyone get a slice of pizza that wanted a slice of pizza? Did anyone not get any? Good.
The gluten-free's still there.
There's still some there?
They're both there, but nobody knew about it.
Oh, there's gluten-free on my left as well, apparently. That's starting to feed back, Rob. All right. It probably doesn't have to be up. Oh, okay. Have we got enough chairs? I think we do. All right. So, welcome to Melbourne CocoaHeads 2018. Thanks for coming along. I've got probably a longer introduction tonight than what I'd normally have. And it's all new slides, and people who have come in previous years, there's less dates for me to get wrong in these slides. But I'm going to start with a really basic, raw introduction. Who is this guy? Who am I? Introduction to CocoaHeads. What is CocoaHeads? What's new in 2018? And then quickly, tonight's agenda, and I'm just going to mention our sponsors as well. And then just before we get into the presentations, we're going to do the who's hiring. So if you're wondering who I am, I'm Jesse. That's a photo of me setting up the sign here 3 years ago, last time we were here. I'm an iOS developer. I've worked at realestate.com.au in the past, a little startup called Bean Hunter, and RMIT at one stage as well. I sometimes forget that. I've been the Melbourne CocoaHeads organizer since 2014, somewhere in there. And yeah, I've got a goal. I've had a goal the last 12, 18 months to start my own startup. So what is CocoaHeads? The logo is a cup of cocoa with a head on it. CocoaHeads was established in 2007, and it's sort of the Melbourne branch of a broader CocoaHeads community. It started before the iPhone. Cocoa's not as widely known now as as the iPhone is, but we're still maintaining CocoaHeads, not the Melbourne iOS developer group. We are casual, an independent meetup. We're not affiliated with Apple in any way or any big kind of corporates. We focus on iOS, macOS development and the surrounding ecosystem. So most of us, back in 2007, most people were kind of hacking on the latest, soon-to-be-released SDKs. now most of us, a lot of us are professionals in the field or up-and-coming professionals, want to be professionals studying this area. So the surrounding ecosystem is software engineering practices, continuous integration, anything that we do day to day. We actually have more than this one event. We have, and I'm calling this event Presentation Night. We also have a Hack Night, which I'll speak about, and Drinks Night and NS Breakfast. NS Breakfast is another fancy naming convention from Apple days, which we might forget in the future, so we'll keep it NS Breakfast instead of just breakfast. So Presentation Night is tonight. It's the second Thursday of the month, 6 till 8:30. Pizza and drinks, as we experienced. Two lightning talks a month, and then a broader half-an-hour presentation. A lightning talk doesn't have to be a sort of a half-assed talk. It just can be a really short one with lots of detail. It could also be an app demo or something that's like, hey, here's something I fiddled with this week. So a longer presentation might be something you'd see at a Yao Connected or a WWDC event or something, just a bit longer. We live stream everything to YouTube. The last few years that's been really successful. As in, by successful, I mean my computer worked most of the time. It's tethering to my phone today. That's been successful sometimes. We're hosted here at YBF Ventures, and we'll be here all year if everything goes well. Our Hack Night is the third Wednesday of the month, and that's 6 till 8 as well. We're going to have introductions, so sort of similar to, not stand up the front microphone introductions, but sort of introduce everyone who's at Hack Night from a 6:30, so turn up from 6 to 6:30. BYO laptop, your iOS project, macOS project. Alcohol-free food, like pizza and soft drinks will be provided, so it's aimed at an all-ages sort of audience. Actually, I've got a slide about that, and it's hosted at AConnects. So this is the blurb from Luke. Where's Luke? He's disappeared. Luke's at the back. Luke's the, I guess, lead developer of the Hack Night.
Chief Dogs Buddy.
Yep. So the Hack Night blurb or pitch is everyone's welcome. It's all ages, alcohol-free, hosted in a professional environment, and you can get to work on your project. Get help from industry experts. Self-professed industry experts. You can be an industry expert if you know anything that you want to tell people you know about. But the idea is to turn up and help out. Drinks Night and NS Breakfast. So Drinks Night is the last Tuesday of the month. This was last Tuesday. There is a laptop there. There's two laptops. And then NS Breakfast is the first Friday of the month. All 4 events will be published on Meetup. I'll tweet about as much as I can, but that's what we run. If you'd like to get involved in CocoaHeads, attending is the first step, absolute first step, very easy. Even more involved, bring a friend, spread the word. One step further than that is, hey, I've got something I've learned or thought of, and you could give a presentation. Attend a Hack Night. And volunteer your time. There's a fair bit of effort that goes into coordinating grassroots events like this, and I'll talk about some people who've been helping me out over the last few months. We're meetup.com/Melbourne-CocoaHeads. I don't think the capitalization matters. And the other ways you can find us are melbournecocoaheads.com, at melbournecoco on Twitter, slack.melbournecocoaheads.com. If it's slow to load, it's because it's on a free Heroku instance, and you just got to refresh it. melbournecocoaheads.com/live is the YouTube channel, and I'm Jesse at melbournecocoaheads.com. So what's new in 2018? Some of you may remember, we took a break from October last year and sort of sat back and thought about things we need to change, or things we'd like to change. Not so much need to change, just like to change. We had a meeting in December between a whole group of us and decided on a list of three main things to change. First thing was a more concise format, and that's what we're experiencing by sitting here now full of pizza. We used to have pizza at 8 o'clock, so that was after the first kind of round of talks. Now we're having it first, and then we'll aim to finish by 8:30 instead of I think we've finished at 10 o'clock before some nights. Yeah. A new hack night is probably the cornerstone of the year, in my opinion. All ages, as I said, all ages alcohol-free. Last previous iteration of hack night was more of a catch-up, more of a social catch-up, which is now called drinks night. So you can see where that went towards. A professional welcoming environment. As I said, we're going to have icebreaker tasks to get everyone to get to know each other who's there. Bring your project, get some help. I think you'll recognise a number of people who are here tonight who are coming, already said they'll come next, it's not next week, it's the week after next.
It's Wednesday week.
The other thing we decided to implement was code of conduct. And Kate, who helped us put that together, is going to say a few words about the code of conduct.
Hello. So yes, in the meeting at the end of last year, everyone agreed that we should have a code of conduct. We formed a code of conduct committee that was myself and Johnny and Sean Woodhouse. I guess a few things. So why do we want a code of conduct? Well, we want to encourage new members. We want to make the community great for existing members as well. We've also formed a diversity committee as part of that as well. So the code of conduct itself.
Do you want to flick that slide?
Yeah.
Yeah.
So this is the first sort of line of the code of conduct. It actually is a lot more than this involved in it. So we also have a reporting process, the sort of outline of the resolution of any complaints. And something to note is that it applies to all CocoaHeads events as well as online spaces, so you should really take a look at the longer version. And there's also a few tips in there for speakers as well to make their talks as inclusive as possible. If you have any comments or you would like to make a complaint against the code of conduct or against someone's conduct,
Either or, both work.
Yeah, this is the address. It goes to myself and Johnny, Sean, Jesse, and I think Ben as well.
Ben Deckies as well. Yep.
So we'll get it, or you can just talk to any of the organisers if you don't want to put it down in writing. But there is more details about reporting in the code of conduct itself. I think that's it.
It's going to be published.
Yes.
It's currently just in a document. I need to paste it into this, but it'll be at code of / code of conduct. So, awesome. Thanks, Kate. I'm really happy that was something we spoke about. Well, we've probably been speaking about it a little bit longer than just from October, but I'm really happy to get that out kind of proactively instead of it being a reaction to something terrible happening or something else. So I'm really happy about that. Before I disappear, I'd like to just say some special thanks. I feel like I'm at the end of the year, but it's the start of the year. But this thanks is to people who've helped out since last year. The Code of Conduct crew was Johnny, Kate, and Sean. The Hack Night people who put some effort into Hack Night was Luke and Stu. Stu helped out with the venue. Speaker wrangling, Caroline, Ben, and Matt helped me out wrangle the speakers. And that'll be an ongoing task throughout the year. That never ends, wrangling speakers. We've got a bit of a pipeline now where we can push people through. Sponsorship advice, I reached out to Rob from the AWS group and also from CocoaHeads and Luke from the Google Developers group about how to coordinate sponsorship. Meetup.com coordination, Marius helped get all the events lined up in there. Again, we'll keep iterating on that throughout the year. Sponsorship wrangling, Prasanna and Michael helped out, as in they pushed a few things up the chain. Actually, there's a couple of other people for that as well. But yeah, thanks to everyone who helped out there. It's been great organising it over Slack the last few months because you don't hear anything for 3 weeks, then it's like, oh, here's a thing. Great. One more thing. I got some stickers. So this is the mug on a sticker. Come up and grab a couple tonight if you want one. They're designed. I mean, they're just the standard laptop stickers, so come and grab some. There is a limited number available, but I won't tell you how many. And yeah, all right, so before I go, I'm right on my time scale here. CocoaHeads sponsors for 2018. Still looking for some more, but I'm really, really happy that realestate.com.au have jumped up to be the major sponsor. Realestate.com.au is, Miles is here from realestate.com.au. Realestate.com.au kind of have an interesting history with CocoaHeads. I think the first event that we ever had beer and pizza was because it was at REA's venue. And they've been around ever since. And they've always put up their hand. So that's great to have REA on board. And our silver sponsors so far, Itty Bitty Apps. Again, same sort of like long history of helping out with CocoaHeads. Sean from Itty Bitty Apps, who's not here tonight, was my predecessor in wrangling all the things. Billu from, actually based in Sydney, but they've got a Melbourne HQ as well. And they've helped out before as well. And J-Tribe too. J-Tribe, same thing. All four sponsors and the potential other ones coming on board have been great over the years. So maybe a quick little clap to the sponsors, the ones that are here. We'll tell them that we clap. The sponsors will be providing the beer and the pizza for both the event here and the hack night as well. So that's how it... yes, and soft drinks as well, sparkling water. And our venue sponsor for tonight is YBF Ventures, as I mentioned. This is them. Thanks to them, that's great. Tonight's agenda. All right, I'm 7 minutes behind, that's okay. We're going to jump into who's hiring next. Who's hiring, if you haven't been here for who's hiring before, is very, very orderly. Put your hand up and I'll go around the room and just say who you are and where you're from and your one sentence pitch, I guess, and then stay around at the end and people will come and you can meet and greet with other people. So I'll jump into that next. Joe is up straight away after that. Why Slack can be harmful, as I promote Melbourne CocoaHeads Slack as a thing. Matt's up after that with The Land Before Time, an app kit journey. I don't think we've had a macOS presentation for a long time, but it's still there. We'll have a quick break after that. That's where we can catch up on the time. And then Hon is going to speak about some core ML stuff after that. So I think Hon is our resident machine learning specialist. We all learned a lot last year when he presented as well. So without any more break, let's go with who's hiring. If you're hiring, you want to just chuck your hand up? Awesome. Now, as the major sponsor, REA or realestate.com.au get to kind of jump up first. You're also sitting in the front, so on my logic, you'd be first anyway.
So Rosanna told me to say a few words. So we're currently looking to hire, I think, a couple of devs on the team that I'm working on, which is the Resi, the Red app, but we obviously have in the building the commercial and flatmates and a whole bunch of stuff going on down at 511 Church Street. So I suppose hit me up if you want to find out more about that.
Awesome. Thank you, Miles. We'll just keep passing it down.
Hi there, I'm Brian. I've just recently moved to Melbourne, so hello, I love it. I'm the Chief Digital Officer at Latitude Financial Services. That's the Alec Baldwin ads, if you've ever seen them on the TV. I've arrived in Melbourne and gone, guys, we haven't got a clue what we're doing with our digital strategy here. We haven't got any native apps, we haven't really got proper APIs, so we're setting about to rebuild everything. And I'm looking for all sorts of talent. So I'm a slow hirer. I like a bit of romance in the hiring to make sure we get exactly the right people. And I'm looking for the whole suite. I'm looking for the UX talent as well as the native engineers. I'm looking for visual designers. I'm looking for behavioural economics. Anyone here at behavioural economics? No?
Can we pretend to be?
Yeah, you can.
They teach us how to
We
be.
pay them loads. Yeah, you should. But look, I'm looking to build up a community here. We're happy to host if you ever need hosts and pay for beer and pizza and that sort of stuff. And over time, do that slow romancing hire of top quality native engineers and some of that other talent that you guys are going to be exposed to regularly. So grab it later if you're interested in a chat.
Awesome. Thank you. Oh, Ashton. Good to see you.
Hello, I'm back. Hi, Ashton Williams from NAB. I'm looking for 2 senior iOS developers for permanent positions on the mobile internet banking app team. It's an app that has about 2 million users, so it's a pretty high impact. And maybe catch me on Slack if you want to chat about it. If you're a consultant, I'm not looking for that exactly tonight, but you can still hit me on Slack and I can forward you to someone else for that. Thank you.
Awesome. Thanks, Ashton.
Just for the record, you don't have to go stand up front if you don't want to.
I'm not good at public speaking. Hey guys, my name is Sama. I do interior design and shoplifting for a restaurant and cafe. I just came up with a good idea with my mates. So we are looking for some people to develop the app. And the app gonna be something creative and big, actually. So it's gonna be something like Uber, but in different industry. And we are going to conquer. So if you think you are creative, we are looking for few boys, sit down and girls as well. So if you guys want to join, but obviously you guys can take as well.
Thank you. Was there anyone else?
Hello. If you don't know who I am, I'm Oliver Jones. I'm the technical director at BBS. We are really busy and we're hiring. And we're not just hiring iOS devs anymore. We're also hiring Android devs. So if you have any friends who are not here, go to Luke Slingman's meetup. We're hiring at them. We're also hiring QA, so test automation, build automation, and also looking for designers and anyone really possible. But yeah. And
Wide net.
we're not really looking for graduates though. We're looking for more senior people. So
Awesome.
come talk to me or hit me up on that code Slack. I'll watch it.
Awesome.
Anyone else?
I might grab everyone's name and details who said they were hiring and put it out on maybe Slack or some method as well.
Should we Slack you so you can Slack them?
All right, we're going to jump straight into presentations. Can everyone hear me? Everyone hear me? Yeah. We're going to jump straight into presentations. Joe, are you ready? Yeah. Awesome. We can go and grab another drink or go to the bathroom for a sec. We'll be back in 5 minutes. Awesome. Thanks. Right. Do you need internet? No. Yeah.
We can't open those windows, can we?
It started to get really warm.
How many of these going to take?
Well,
How many laptops do you have?
That, all right, good.
All right, all right. Hello, hello. Hello, hello. 1, 2, 3, 4, 5, 6, 7, 8. Hello, hello. Hi, everyone.
Hi, Joe.
I'm Joe, and it's really an honor to be the first one to present in 2018. And before we get into it, I would really want to ask you to give another round of applause to Jesse and crew for setting this up. It's really awesome. So, I work for a company called iFlix. iFlix is the movie streaming service for emerging markets. And I'm in the lucky position where I get to think and work a lot on the team productivity and efficiency. So let me ask you a question. How many of you use Slack? Okay, almost everyone in the room. HipChat or any other instant messaging for work? Yeah, some other hands. Yeah. How many of you have checked Slack or equivalent since you've been here tonight? Yeah, I did too. Yep.
But
So-
not the work Slack.
Okay, well, the work Slack. So, as I said, I think about productivity and stuff, I do experiments, and I came to this conclusion, which is that Slack is harmful for your productivity. And what do I mean with this? So, if we define productivity as the amount of generated business value, the actual, like, say we write code, the actual useful code that you write, the one that goes out to the users, the one that makes the app better, the one that makes money to your employer or yourself. Well, if that's what we mean by productivity, and we put it here, and this is the time that you spend on Slack, I would say that this is how the relationship between them goes. There's a certain amount of Slack that is actually useful, and after that, it just becomes a burden on your productivity. And mind you, this is based on no data whatsoever, only a personal opinion and empirical experience, all right? So take it with a pinch of salt. But yeah, this is what I've seen, and I see like, you try to work and you get interrupted, and then you reply, and then you're sidetracked, and, it just gets in your way. So I came up with the SLARU Pro WO, which is the Slack routine for productive work. The 4 is lowercase because it's not in the acronym. So this is how the SLARU Pro WO goes. You set yourself as a way. You set your status as something like, emoji of choice, working deeply on feature X. Then you can snooze your notification for 1 hour or any amount of time that you think you're going to work deeply. Unfortunately, Slack doesn't have a keyboard shortcut for snoozing notification. I hope they're going to add one soon. And finally, you quit Slack. This is all to make your colleague aware that you are not slacking off, and this is to actually make you productive. And if you get worried, that like, oh my gosh, I'm going to go off Slack, what's going to happen? I've been trying this myself for the past month, not really every day, but a number of times a week. And this is, no, you're all seeing everything. Ruined it. This is what happened. I got lots of work done in my time away from Slack. I felt good about the rest of the day, because even if I sort of got distracted and got called into things that, from my point of view, weren't as high a priority, at least I had already done something good, something useful for iFlix and the team and the company. And had a lot of fun, because I was sort of working my way through code, being challenged by problems that I needed to solve. It was good. It was really fun to go to work. And these are a few things that didn't happen. Nobody died. Nothing caught fire while I was offline, and I didn't get fired. And no one overrode the snooze notification courtesy, except for one person, which I ignored. So I would encourage you to try the SLARU Pro WO, and let me know how you go. Your mileage may vary. So at this point of the talk, I hope that you're going to be like, why should I trust what you say? You know, who are you? Where does all this come from? Well, you shouldn't trust me. You should never trust something that, you know, random people tell you in a talk. Go back and verify it yourself. That's why, you know, you should try the routine and tell me how you feel about it. I have a few other questions. So, how many of you have checked Twitter, Facebook, social media since you got here? How many of you have checked Twitter, Facebook, email today? How many of you have ever received a tap on your watch or a notification on your phone while you were having a conversation with someone and just took out the phone or looked at the watch while you were talking with someone? I've done it plenty of time today as well, while I was speaking with someone, sorry. So, as I said, I kind of like reading and learning and experimenting about productivity and efficiency. And there's two books that I would really recommend everyone and that they've been very impactful for me. The first one is Peak from Anders Ericsson and Robert Poole. And Peak talks about what it takes to become a top performer, like, you know, Olympic champion of whatever, grandmaster of chess, solo violinist player. But it starts with a lot of like scientific theory on the brain. And it taught me about neuroplasticity, which is the concept that, unlike it was believed a few years ago, our brains are actually always in motion and they're always remodeling themselves. And we can affect our brains the same way we grow our muscles going to the gym. We go to the gym and we grow our muscles. We train our brain in a certain way, and we can actually grow the area of the brain that takes care of that function. Another concept that is exposed in Peak is the concept of homeostasis, which is the fact that our bodies and our minds are made to become efficient at everything that they do. So if you go to the gym and, you know, lift weights, if you want to grow more muscles, you're going to have to lift heavier and heavier weights because your body is getting used to it. I never thought of that, and they're very interesting, and they're going to come in handy later. The second book that I would really, really recommend you, what I think should be the Bible of the software developer and knowledge worker, is Deep Work from Cal Newport. Deep Work is a long argument towards the value of focus and being focused at work, especially for software developers like us. And it contains a lot of strategies for focused work, for building focused work in your life, in your day. That's sort of what gave me the idea of the Slack routine. Something that is quoted in Deep Work is this study, Cognitive Control in Media Multitaskers by Ophir, Nass, and Wagner, which was published in 2009. Look, I couldn't really summarize the study for you, but this is what Christopher Nass tells about the study in an interview. I'm going to read. The people we talked with continually said, look, when I really want to concentrate, I turn off everything and I am laser focused. And unfortunately, they develop habits of mind that make it impossible for them to be laser focused. They're suckers for irrelevancy. They just can't keep on task. This really hit me off. So I just learned about neuroplasticity and homeostasis and how, you know, the more we do something, the more our body gets accustomed to that and we change our brain to be more effective at that. Then I learned that the more we try to multitask and get distracted, the sort of worse we get at focusing. And I went, this is scary. What am I doing with my brain? And that sort of set me off on a little personal journey to try and reduce distraction in my life and try to get back focus. So I would encourage all of you to do a favor to your brain and stop multitasking. I'm Joe. You can find me at mocacoding.com, joe@mocacoding.com. And I have a newsletter in which I haven't written for ages. But I'm trying to, write stuff like the one that we talked about tonight. And that's the link to subscribe if you want. Thank you.
Any questions for Joe?
Any question?
How long's your journey been so far?
How long? So I read Deep Work in March last year. So 9 months. Yep. I still get distracted all the time, but I am aware of being distracted. So how many of you, when Xcode is building, you sort of stay there and say, oh, let me check something else. Let me check something else. I get the pattern of thought in my head and say, no, stay there, keep looking at that bar, because you need to stay focused on this. And maybe I use that time, that incredibly long time, unfortunately, to think about what's going to be my next move in my coding, for whatever I'm writing. Yeah. Any other question? Class?
You mentioned Slack as I understand correctly, the team communication channel for many people, but many other teams just use human communication as that channel. Would you consider human communication also harmful if it's a out-of-bounds distraction?
That's a very good question. The question was for all of you in the YouTube stream, so I can see if I got it correctly. Would you consider human communication, human interaction as toxic or dangerous for focus as Slack is? Sort of. There's a big argument to be made against open office floor plans and how maybe we should have our, if not cubicles, like little team offices. And there's also things like the headphones rule. If I say, hey, the same thing as Slack, I want to deep dive into my work, stay focused, make the best work that I can, and earn money to my company, I'm just going to put my headphones on, and no one is going to interrupt me unless something is on fire.
It's useful to have in those situations, because a lot of people just listen to music in offices and don't know whether or not they're listening just for pleasure or for focus, usually for focus. You can make use of things on your desk, like if you've got a little sign, it's like, please don't disturb.
Nice. Oliver's suggestion was to use something on your desk, a token that says, hey, I'm in focus mode, please don't disturb me unless it's necessary.
Sometimes in that signage is actually like have an indication of when people should can come and talk to you. So if you want, if you undisturbed hours, you can say, please don't disturb, come back at 3 o'clock.
Yep. A remix of the routine that I use sometimes goes, I'll be back at 12 or whatever. Yep. Another question?
Hopefully the last one. Now, I wonder how you balance the productivity benefits of basically setting a do not disturb mode for yourself versus a potential productivity benefit of answering a question your teammate has.
Yeah. That's a great question about questions. So how do you balance, the productivity benefit that you get from being undisturbed with the benefit towards the team that you could provide by answering a question that a teammate asked? I don't have a good answer for that. There's a few chapters of pieces of deep work that kind of bring the example of Jack Dorsey and how he's all about, I'm at my standing desk and anyone can come and interrupt me. I think it's all about balance. I try to be as available as I can for my team, and I try to schedule my work, my day, so that I get most of my stuff done in the morning, and then I have the rest of the day to react to requests. Your mileage may vary. If you are in a different position, you might find a lot of benefit by being offline for an entire day. I don't know. But I'd like to hear about it if you want. So come and grab me. I'll publish them on mochacoding.com / something, which I'll paste on Slack. Because, you know, it's a curve. If you use it a bit, it's useful. Thank you.
One more question. So, if you were designing the ideal engineering workspace in a large open plan office, which I've got to do, what would you take out of deep work to help set it up so engineering can work as effectively as possible?
Yeah. So the question was, how would you design an open plan office to create space for engineers to get into deep work? I don't know, I'm not a floor plan designer. The book has an interesting chapter on this ideal place for deep work, which is a series of chambers that, you know, you go through them and you're more and more into depth, but that's not an answer to your question. I would start with like maybe some pods out of the way and maybe facing the wall rather than the rest of the people. And maybe there could be this convention like, hey, if someone is over there in the pods, just leave them alone. They'll be back when they can.
Some organisations here in Melbourne that have moved to activity-based working or have large open plan offices set aside space in that office for quiet spaces, and they're often of varying levels. Like they often have a library, which is complete like silence, like no one can talk in the library, or they'll have other quiet rooms or less quiet but still secluded pods or something that you've got just open desks.
Good. Works 18. It is so far a very good year, but I am going to talk about something from a long, long time ago, the land before time. And I'm going to talk about this thing called Mac OS development. It's pretty awesome, I love it. And my journey so far. So, hi, I'm Matt. For those that don't know me, I work for Baloo. I've worked at a few different places, but now I'm working for Baloo, which is a really, really good consultancy in Sydney and Melbourne, but I'm not here to talk about that. Tonight, I have this thing, a lightning talk. No one complained.
Notorious, man.
Yep. Okay. Yep.
I thought I'd put a new timing thing to a test.
Yeah, so everything either succeeds wonderfully or fails based on my talk. Yay. I am looking at the clock, so I will do my best to actually make sure that this is a lightning talk, Scout's honour, all that stuff. First, a bit of a caveat. What I say has every chance of being wrong. I am very new to this macOS thing. I've attempted it a few times in the past, but ultimately I tend to fail at this because it is very different from iOS. Why am I giving this talk? I'm giving this talk for two things, mainly for very selfish and personal reasons. I want to consolidate what it is that I've learnt, and I want to actually try and demystify this whole thing around AppKit. Fairly ambitious. Okay, getting started. This is the one very, very big hurdle that everyone has to get over. And compared to the wonderful world of iOS, macOS has a very large hurdle to get over. It's not as well documented, there aren't as many tutorials, and pretty much nobody is talking about it. Everything is iOS based, it is Swift based, it is developed for the iPhone or the iPad, and the Mac tends to be neglected. So, what are our sources for documentation? These are pretty much books, more books, and Apple's documentation. So, yeah, not many blogs, not many Ray Wenderlich tutorials. Ray does have a few tutorials on getting started with macOS and AppKit, but there isn't the breadth that there is for iOS. So a lot of stuff you will have to try and piece together by yourself. Unfortunately, this is just the nature of it and something that has to be lived with. So if you hear about people talking about the big Nerd Ranch book, get yourself the latest copy, read it. It'll explain a whole heap of things. Books, physical copies, digital copies are going to be a friend as far as references. Not much has really changed in AppKit, like the general basics and structure of things recently. So yeah, books are the best option, as well as Apple's documentation. Now this slide is probably an offensive one to some people, but when you're getting started with AppKit or even iOS, MVC, Apple's default architecture, is actually a very, very good way of going about things. There is nothing sort of special or different you need to be thinking about. You just have a model, a view, and a controller, and you break things down as much as you want from there. It is a very easy and a very good, straightforward way of achieving things. So, that's the basics as far as sort of what I'm trying to go about explaining in a roundabout way. Now, let's sort of look at some of the bits and pieces that are going to make up a macOS app. The first of those is this idea of a window. So, who here knows about a window, as in a UI window in iOS? A fair few people, that is good. It's not really a thing in iOS apps in that you just assume there is a single window, which is the window of your device. I've overheard people saying, oh, in order to do this thing, I've presented another window on top of a window at a dub lab, and you just see people facepalm and you go, no. That is very different in a macOS world because your apps are windows. So you've got the box, which is your window, and it has a view, which has a view controller, and there are multiple views within it. You all know what a desktop app looks like. That is a window being presented. Now, your app can present multiple windows. That is a perfectly fine thing to do and something that is often expected. So what is a window and a window controller responsible for? It is responsible for the document. I'll get to this idea of a document in the next slide. It contains your views and your view controllers, and as I said, there can be more than one. NS document. So who here has played around with UI document? Yep, and you all know how horrible and painful that is to use. NS document isn't like that. NS document is actually very nice to use, and it'll end up being your best friend. Why is it going to be your best friend? Because everything on a desktop is pretty much a file. You're dealing with files all of the time. You're not dealing with, I'll just post web requests and get stuff back. You're dealing with data that typically sits on a disk. So if you then want to get representation of a file that is useful presenting in a window, NS document is the way you go about it. NS document gives you your file reading, file writing, renaming, everything. And Apple's documentation is the best option. NS View. So again, iOS, you have UI view. Everything is sort of represented in different views. On macOS apps, you have NS View. But there are a few differences. In macOS, your coordinate system is not in the top right, as it is with an iOS device. Sorry, top left. It is in the bottom left. So it starts from there, and you then go positive in each direction, like a graph. The other thing is by default, there is no layer backing to an NS view. Everything is part of the views, and I'll show a few things around that later. NS Box. So who has done like old school Java swing interfaces from uni days? Yeah. And typically you would sort of get a group of views and you'll like put an edge around it and you'll put a title. That's what NS Box is, but you don't need to worry about the outline or the title on it all the time. NS Box is actually a very good way of grouping a whole heap of views into one sort of thing that you then go about and modify or use. NSL. Everyone seems to have an opinion on this, good or bad. I thankfully have not had to deal with NSL in anger just yet. It sort of shows how new to macOS development I am, but it is something to look out for. NS Grid View. This is something I like. So we have stack views in iOS, which allows you to lay out something either vertically or horizontally. NS Grid View is a new thing in macOS. I believe it came in Sierra. I think maybe people are nodding half-heartedly. Yep, okay. And it allows a two-dimensional stack view. So you can lay things out in rows and columns. This is really, really good, and I like it. It's pretty cool. This one, the NS Outline View, is something you don't have in iOS. In macOS, if you think sort of old school, representing of, say, a file structure in a view, you've sort of got this tree format, or even in Xcode on the left-hand side, you've got your groups and your files and all that. That's something like an outline view. So instead of just having a straight table or a collection, you can have something that acts a bit more like a tree. I tried playing around with this years ago, and back when I was first sort of playing around with stuff, and the ideas of delegates and data sources confused me then. But realistically, that's how a lot of AppKit stuff, a lot of UIKit stuff works, is this idea of delegates and data sources. So, these guys are your friends. They're the building blocks of most of Apple's, as far as I can tell, may be wrong, actual architecture and design. Uses data sources for getting everything, and then delegates for saying stuff has actually been done. It has been around for a while. I don't know when the idea or the pattern was first introduced, but it is pretty damn good, and I think it should be adopted a lot more. If you're wanting to sort of understand UIKit and AppKit and how they behave, delegates and data sources are good options for really trying to get your head around because they're used everywhere. Collection views, again, very similar to how UI collection view works. I think NS collection view actually came about after UI collection view. So this is something where AppKit has adopted from iOS, and it's pretty cool. So there are similarities and there are differences. Apple's documentation is really good on this, so go read it. Views, again, much the same. You're laying everything out sort of one underneath the other, but with table views, you've got this idea of double clicking, which you don't have in iOS. In iOS, it's always a single tap as your interaction. In AppKit, you can double click something. So NS table view has all of the delegate callbacks for handling that as well. You can use NS table view cell or NS cell, pretty cool. This next thing is magic, view bindings. So in iOS, particularly when you're doing an UI in Interface Builder, you have no way of sort of tying the interface directly back to, say, a key path or something like that in your model representation. In AppKit, you have view bindings, and they are magic in that it will create the link from your UI and say, I want to go to this array controller or this collection and grab this particular key path. It is pretty damn cool and impressive. It's magic. Magic is real. Unicorns are real. Get used to it. Interface Builder. Controversial, but Interface Builder is awesome. Makes a lot of sense when doing Mac OS apps. It makes your life so easy, particularly with view bindings. Storyboards are your friends. Just use it. Stop doing stuff in code. If you do it in code, it's a maintenance nightmare. Okay. Layer-backed NS views. So earlier I made reference to this idea that a view doesn't typically have a layer, and it doesn't. Your default for an NS view is without a layer. You can, though, say to your view, I want to be layer-backed, as in controlled more by the graphics hardware than the CPU, fun stuff like that. In iOS, we would typically do something like this. We would say view.layer, background color, set it like that. This, from what I know and understand, is a fairly big don't do in AppKit. People smarter than me will probably tell you why. I'm just starting to realize this. I've done this many times in my code. Don't stress about it, just realize you're not being as effective with everything as you could. One alternative I found on the Objective-C.io, this is old Objective-C.io before talk, and they did an AppKit article mentioned about doing views and particularly a background view like this. I think this is pretty cool. Okay, so one of the things to realise is that with AppKit, because it's been around for so long, there are many, many opinions. These are the things I've sort of realised by talking to people. Trust Apple. They probably know what's going on with Mac OS and how apps should interact a lot better than you do. So if they say do something in a particular way, do so. Second, don't try to work around AppKit. Try to make use of it. So if you find yourself doing a whole heap of dodgy hacks or something, you're probably going down the wrong path. Anything that's private, just don't use. It's private for a reason. There's no guarantee about it. Just avoid it at all costs. And make sure you test everything. With the macOS app, whether it's unit testing, whether it is some other kind of testing, make sure you test as much as you can, because there is far more ways to break stuff than there is an iOS app. Last slide, where to from here? So I'm just starting out with AppKit and it's pretty cool. I like it. I would actually challenge everyone to think of a desktop app that they want and go about developing it, just learn it. It's great for understanding how a desktop app works in relation to an iOS app, but it'll also give you a good understanding around how iOS and UIKit is meant to work, because you'll see how it's a progression from AppKit. As I said, I'm still learning this stuff, but it's pretty awesome, so go out and make some pretty awesome things. Thank you.
Have you published anything on, or tried to publish anything on the Mac App Store? How is that equivalent to the iOS App Store in your understanding at this point?
Okay, question was, have I published anything on the Mac App Store? How is it different from the iOS App Store? Yada, yada, yada. Big, long, we probably should get Sean up here to answer this, as he's much more knowledgeable than I am. Having said that, my intention with my current side project is to publish on the Mac App Store. I think for a very sort of small and focused app, not to say that other apps aren't focused, but rather for what I'm wanting to achieve, I think as a side project, as an indie dev, having the Mac App Store is it's an amazing thing, and it allows me to reach a lot more people than just publishing elsewhere. That's probably all I can say on it. Any other questions? Luke?
You mentioned NSL. I'll just give you a little bit of history about it. It's a really lightweight in its view. And the reason that they initially put it in was they wanted to make a calculator app. And machines at the time didn't have enough RAM button for the calculator as an actual button. So that's why NSL and things like that. So you've got to remember that AppKit goes back to like 1984 or something silly like that. With the next, that's where NS comes from, this next step. And things like NSL, it's like, think of a machine with a 25 megahertz processor and 4 megs of RAM. So, yeah.
Absolutely.
So the iPhone is just like, it just wastes most of its power.
25 megahertz is electric. They started on the 111, which is the 1 megahertz, 1 meg of RAM, and I can't remember what the other one was. Oh, 1 megapixel display.
As a comment, if anyone does want to talk to people about Mac apps and people who know what they're talking about, talk to Tubbs, talk to Glass, talk to me, talk to Matt.
And I believe Grant, and if you want to talk to someone who's actually doing it in the real world, at Hack Night, a little bit of a plug, Grant from Rogue Amoeba, who just shipped Virago, Grant was the lead developer on that. He knows way more about developing Mac efforts than anyone.
My challenge this first half of the year is to get Grant to come and give a presentation. I said, you don't have to prepare anything, just show us your app. We'll see where we get with that.
Yep, so who else apart from Jesse and I and those previously mentioned wants to see Grant present? Everyone? Cool, done. We'll make it happen.
Yep.
Thank you.
Matt.
So we're just going to take 5 minutes. We'll come back at 1:45, so have a walk around. The bathrooms are just out there to the left. I'm sure Luke can direct you as you go. We'll come back in 5 minutes and we've got on some awesome machine learning stuff.
Awesome. We're doing what is it? Airplay.
Yep.
I keep forgetting all the brand names now.
It's been around for a while.
I know.
We've been using it for a while.
Oh, we've got stickers at the front as well. Grab some stickers too. Now's a good time.
Do you want space or?
Yeah, you got a space.
I don't want to include anything, but.
Ooh. You've been pretty liberal with the ones you've got.
I know. I was like, oh, I'm done with the stickers.
All right, so that's good. Good to go.
Test.
Yep.
Can you hear me? Can you hear me? Hello?
No, there was all the stickers are gone. That's phenomenal. That's awesome. Oh wait, hold on. Hold on, they're still gone.
All right, maybe I'll use this.
Over to you.
Hi. I'll just wait for everyone to sort of settle down a bit. While that's happening, brief introduction. My name is Han. I'm the co-founder of Clinic Cloud. We're now called CC Labs. We do a lot of machine learning in the business, primarily in medical data. So I've been dabbling a lot with machine learning for a while, and I thought it'd be very interesting to see what we can do with Core ML particularly. I think I did one talk about Core ML immediately after DevDub because I was really excited about it. I've been playing around, and since then there's been a lot of very interesting developments. So I guess one of the big highlights is that TensorFlow is now fully supported using TensorFlow Lite. It converts down to Core ML. Along with TensorFlow, there's also a lot of big players like Facebook coming in with PyTorch, Microsoft as well with CNTK, having support for ONNX, which is the neural net compiler, and now you're able to build very interesting machine learning, deep learning models using a whole variety of frameworks. So given that this is a bit of a weird area where it straddles data science, a bit of iOS, Mac programming, and there's a bit of Python and some stuff. So I just wanted to get a feel of things. Who here has actually dabbled in Core ML? All right, and who here has actually built neural nets and played around with deep learning models? Cool, all right, so. All right, so given that that's not that many hands, I'll try to go as much as I can. There's a lot, so let's whiz through it. So topics to be covered: background in natural language processing, word embeddings, recurrent neural networks, Keras, TensorFlow, Core ML, and I might give a brief peek of the automated workflow that we've built for Android and iOS using Python templating. So first up, what is natural language processing? So NLP is a process of having machines understand language. The best example is Siri. So when you talk to Siri, you're not speaking machine language. You're not saying in a very structured way, hey, play music, I want genre jazz, Louis Armstrong, year of 1967. We're saying it in a very naturalistic way, which is playing a jazz song from Louis Armstrong. Now, the problem with language, especially in languages, very ambiguous languages like English, is that there are lots of different ways of saying things, and not necessarily all of them will convert. And so writing regular expressions to do all of this would be a nightmare. So this is where machine learning comes in, where you feed a lot of examples and you try to get the machine to parse out the structure of the data, right? Because after all, in lots of data, we'll find interesting architectures, interesting patterns that we can then architect machine learning models to then parse. So iOS 11 has built-in natural language processing. Some of you may have already played with it using the NS Linguistic Tagger class for tokenization, lemmonization. So for those of you who are not familiar, tokenization is when you give it a string. So the cat sat on the mat, and it then passes it and creates tokens. Tokens are individual words. So the cat sat on the mat are each individual words. Lemmatization is when you give it a word like, say, running, and you say, give me the stem of the word, and it'd be run or swimming. Swam became swim, or swimming became swim. So that way, you can have all the variations of past, present, future tense and such, but they all mean the same thing if you don't really care about time. So lemmonization is very good for that. What I'm going to be talking about is what we've developed using Core ML for intent classification and slot tagging. Intent classification and slot tagging is a method that's currently being used by a lot of vendors. So Siri uses that for parsing out that sentence there, playing me a jazz song Louis Armstrong from 1967. Cortana does that for Microsoft, Alexa, and I think Google Assistant as well. They all use the same technique, which is essentially saying, if I give you a string of text, say, play me a jazz song from that, I want you to tell me what is this thing actually wanting me to do? That's the first step, which is the intent. And then once we have the intent, we can then go down further and say, given this intent, what information can I extract from this? And what you want to do is you want to end up with a JSON or some sort of structured text that says the extracted entities are genre jazz artist Louis Armstrong in the year 1967. So let's move on. So a lot of people would say, well, why do you want to do this on mobile? And this is an argument that's, it applies to all of Core ML and edge inference. So the pros of doing it on the edge is privacy. No data leaves the device, doesn't go to the cloud, no one's peeking at it and trying to sell you ads. Cost, you as an indie developer or anybody don't actually have to pay Amazon or Microsoft, credits or whatever to actually run these algorithms. Availability, well, if you go outside of coverage and you go into places with 2G, you still can run this stuff offline. So that's an advantage of that. And speed, well, if you're in 2G area, then you're going to have slow speed, so running on device is going to be good. The downside is flexibility, and I'll talk a little bit about that going further. The flexibility that comes with building on devices is limited. You can't change models, and we know with machine learning, you're always trying to update it with new data, new model architectures, new hyperparameters that you've then built. Memory, that's a really big issue. So I'll talk about word embeddings coming up, but word embeddings take a lot of memory. There have been attempts to what's called quantize them, which is reduce weights from float 64 down to int 8s and try to maintain accuracy. But that's still really a big challenge at the moment. Compute. So when you're doing these processes, they do a lot of compute. And so it drains the battery life. And difficulty. It's rather more difficult to actually try to get it to work on the edge. So the first step in any machine learning process is data vectorization. When I say data vectorization is, if given some piece of data, how do I turn this into a vector? Because a vector is what we feed into machine learning models. It's really important. I cannot stress this any further because there's a mantra in machine learning which is garbage in is garbage out. If you don't feed it the right data and you end up with really bad results, the best thing to really do, two things if you're doing deep learning is A, lower the learning rate, and B, check your data. So saying that, things such as images are naturally very good as vectors. In this case, they're actually tensors. So when we talk in machine learning land and in math, we go by hierarchy. So a vector is like your arrays, right? So a vector is an array. A matrix is an array within an array. So that's a two-dimensional vector. And then when we talk about tensors, we talk about ranks. So we talk about third rank, fourth rank, fifth rank, which would essentially be, if you look at this thing, a construct like an array of an array within an array and an array. So it keeps getting embedded inside itself. So here's the really interesting question. How do we deal with words? How do we vectorize that? And I'm going to show you two ways. The first way, which is really simple, is what we call one-hot encoding. So one-hot encoding is what we call a sparse representation. Sparse because it takes up a lot of space. So if I had this word, hello world Taylor Swift, nope, right? What we do is we say there are like 1, 2, 3, 4, 5 words, so therefore it's going to be a vector of size 5, and each time, each spot in that vector, I'm going to put a 1 in it. The problem with that is if you have a very large corpus of words, say let's say 6 billion tokens, like what, no actually no, 6 billion is a bit too much, so let's say 250 million, which is what Wikipedia kind of has. You're going to have a 250 million row by 250 million column matrix. And these are all floats, so you can do the math and your memory just explodes. So word embeddings is a solution to try what we do to densify the vectors. And what makes a good word embedding? Good word embeddings are ones that actually capture the meaning of the words, and we call this semantic representation. An example of semantic representation is in this graph. I'm sorry if you can't really read it or see it, but what it's actually saying is, say, if in a very high dimensional space, I took the word king and I looked for the word man. If I drew a vector directly from man to king and then took that vector and transposed it to the word woman, it should point to queen because it should learn the representations that man is to king, woman is to queen, and so on and so forth. So there are numerous ways of doing it. lots of different techniques. The most commonly known and most famous is word-to-vec, which is what's called a skipgram model. So given the last 3 words of a sentence, I want you to predict me the next word. And then you have a bag of words and glob and so forth. But what's really interesting is that by doing this exercise of saying, given the last 3 words, I want you to predict the next word, the model learns that certain words are closely associated with each other. So you can say things like, all right, I'm going to give you an analogy. Melbourne is to Australia as to something in Germany, and it might come up with Munich. Even though no one explicitly said that Munich is in Germany. Okay, so moving on, artificial neural networks. Artificial neural networks is going to be one of the topics of this talk, is a way of doing machine learning and deep learning. It's probably the best at the moment, but there are lots of different ways of doing machine learning, as support vector machines, k-nearest neighbors, but this has been the one that's given a lot of promise. So word embeddings like fast text and glove and word2vec are also built using artificial neural networks. And when people talk about deep learning, don't be fazed by it. What it really means is that there are multiple layers in the neural net. So that's just a fancy way of saying it's really complex. Once you look at it, it's actually really simple. So what a artificial neural network actually is a linear regression model or logistic regression model with a nonlinear function applied to it. So what gives artificial neural networks such good representational power is this nonlinear function. So I promise this is the only maths you'll see in this talk. So given like x1, x2, x3 as inputs, as numbers, I want to calculate the sum of the product of that, and then I apply a function that says this is either on or off. But you don't have to worry about that because a lot of the frameworks take care of that for you now. So moving on to recurrent neural networks. So there are a lot of different ways of putting together neural nets. And just think of it as Lego. You have all these blocks. You could make a castle. You could make a Millennium Falcon, whatever you want to do with it. And neural nets are pretty much the same thing. So when we talk about convolutional neural nets, it's essentially a way of piecing together all the neurons to look at the data in a certain way. So there is a family of neural network architectures called recurrent neural networks that are very good at sequential processes. So what I mean sequential is that you have a time step of -1, 0, and 1, and you want to predict the next thing, or you want to actually classify a sequence. So the reason why is because they have what's called memory. So it knows what happened in the past, so therefore it can predict the future. The problem with recurrent neural networks, which is the grandfather of all of this, which is that first graph here, is that there's a problem of the vanishing gradient. So in neural nets, we follow the gradient through stochastic gradient descent to end up with a minimal point to get the best prediction. The issue with recurrent neural nets is that if you take, a good example is if you took a tangent and you took a tangent of the tangent and then more of the tangent, you end up with just a flat line. So what we do as tricks to do it, to fix this vanishing gradient problem is what we call the long short-term memory cell or the gated recurrent units that have specific units in here. You probably can't see it, but these are forget gates. So as the data flows through, the neural net decides whether I want to keep this or I want to forget it, so therefore it doesn't accumulate too many gradients. Don't have to worry too much about this because Keras takes care of this for you. So I just want to talk about the model, the framework that we've built. Essentially, we built a React web app that connects to a TensorFlow training server. We have a fast text word embedding that we pull the embedding words. We then train a model and store that into a Google Cloud bucket. We have the same web app as it runs, pull the model from that, and we send it to, in the case of Android, we have a Docker image that runs in Google Cloud that builds the project using Gradle, and an iOS build server that runs on Mac Stadium that runs a Flask server that has a continuous queue that pulls jobs and builds the framework. So fast text word embedding. So fast text word embeddings were chosen because it's currently the state of the art. It gives very good semantic representation. We used a pre-trained gigawords corpus, about 6 billion tokens that's been trained on. It takes about 8 gigabytes worth of RAM, so this is the problem why you can't really run all of it on your phone. And so what we did was, as a hack, was we took each word that we use in our training corpus and we did a Euclidean distance search, essentially saying if I had this word, find the 1,000 closest words in that space. and then we added that into a SQLite database of 300 number vector. So once we had that, we are able to train the model in Keras, using Keras on TensorFlow. The reason why you want to be training using these semantic representation word embeddings is that it already captures a lot of meanings in the word. So if it sees, for instance, the word coffee in the same space as, say, the word tea, then what that means is, these words are very similar and highly related, so therefore I will tag it in the same tag. So going on with Keras, Keras is for those of you who never played, is a high-level abstraction over multiple backends. So it supports TensorFlow, Theano, CNTK, and I think AmexNet right now. The cool thing is that it's CoreML compatible. So the team at CoreML have worked really hard to make sure that most of Keras is working with it. There are some caveats such as recurrent neural network paddings, but there are ways of going around it. So the best thing is that it also has TensorFlow has very good Android support. So the workflow that I would highly suggest if anyone's trying to build machine learning models is to use Keras on TensorFlow, build it for CoreML for iOS, and then take the model, convert it into TensorFlow, and run it on TensorFlow for Android. So CoreML, going really quickly, is the team at Apple have tried really hard to make sure that the transition from data science to iOS and Mac is as seamless as possible. So they actually modeled it after NumPy. NumPy, for those of you who never played, is a numerical analysis tool for matrix multiplication and very fast math. Now the crucial thing, if you guys are really interested about CoreML, the only thing you really have to know is ML multi-array. That is the most important class in the entire framework. If you know how to manipulate ML multi-array, you're flying. You can do anything with this stuff. And converting CoreML is so simple. It's just a single line of code. Now, there is a caveat again. CoreML is statically compiled. So you need to know beforehand what your inputs are, what your outputs are like, and the whole names of your processing flow, which is a problem because I'll come to that now. So this is Python code. So this is essentially a snippet of Keras. Keras is a way of defining a model of how I want to do things. In this one, it's essentially a sequential model. So I'm saying I want an LSTM, which is a long short-term memory cell that takes. So what's really interesting, if you look at the red area, input shape of none and 300. What I'm saying here is that I want Keras via TensorFlow to, at training time, not runtime, training time, determine the length of my sequence. And then each token, each vector is about 300 numbers long. So that's important. The second most important thing is that other one that I've highlighted, which is the number of labels, right? Because what happens is that at the output neuron, the output neuron is going to say, well, there are 6 things I want to classify, so therefore I will only have 6 neurons. So you need to know those are the 2 most important things: what the shape of my input is and what the output number is going to be like. It's really easy to do this in Python land because it's dynamic and you can just pass the arguments through. But again, as I said, CoreML is statically compiled. So that's a potential problem. However, remember I said CoreML models are statically compiled, but if you can manipulate ML multi-arrays, anything is possible. So this is going to freak out some people, but what we actually reverted to was Ginger templating, which for those of you from PHP land, maybe Ruby on Rails, whatever, are very familiar with the concept of templating. So what we do is, at the end of the training phase, we look at our model and we say, all right, what is it that we had output? So for something like that, we say, all right, we have a type that is an intent classifier, the name is the utterance intent, and so the intents that we expect are make, weather, news, recommend, and help. So those are 5, so we can quantify the 5 of them and they're in order. The order is really important because that's how you train it. And then we say in iOS, we have a file name called the something.ml model that we're going to include. And then the 3 most important things, which is the input operation name, the output operation name, and the input shape, right? So what we do with that is we look at that JSON, we write some Python code and do some templating. So we say, all right, input shape is 300 here. We have a template, Objective-C, unfortunately. We have a template in Objective-C that takes the input shape that we have in the config and then writes it in. So what happens is that we have a whole bunch of H&M files that are correct for the ML model. And then what we do is we take Xcode Gen. I don't know if anyone's played with Xcode Gen, but it's pretty cool. So what we do is when we do the fast text training, we also get a SQLite database back with all the vectors. We take the SQLite database, we take the H&M file and the ML model, and we smash them together to get as a Xcode project that we then use Xcode build to get a framework. And then what we do with that is we put it into an app. I don't know if we have time for demo. But...
We've got time for demo.
Okay, cool. All right, so this is the web app that we kind of developed-ish. So and we have a pre-trained model here. So in this we have, say, coffee, and we have entities. So we have drink, number, percent, quantity, milk that I want to actually tag. I have sentences, so these are all the sentences that I want to do it. If anyone's played with Alex, it's very similar, or Louis from Microsoft. So in this case, what is it? It is, so if I can go back to this intent, if I look at coffee, sorry, React, not my specialty. Go here, we can go and edit, and I'll show you what it looks like. Make me a coffee. So what this is really simply doing is that it's getting a sentence, we're just tagging it, and we get a CSV file. But we are able to then go, say, click on train module. So what this does is we, using Kubernetes, send the export JSON that has all the right tags to a Google Cloud instance, and it's at the moment training a machine learning model. What happens then is that model and its intermediate files with the ML model and the TensorFlow files are kept in a Google Cloud bucket. Once that's done, we're able to click on the iOS, and we get an iOS framework. But what I was going to do, can I actually do it? Maybe I can. That's my... I can't get the SSH, but I'll show you what I've done. This is like cooking, television cooking. I have a pre-made screen recording, and then I do phone, I think. Yeah, here we go. Okay, so what happens is that once you've trained the whole thing, oh, keepers. Wait, no, microphone. What? Oh, right. File, new movie recording. Recursion. Here we go. So iPhone. So this is just the demo app that we built. And if given this thing and I type in the word, so here's some text that I wanted to classify. Make me a mocha with more milk. And this is not connected to any internet, but I'm able to go, all right, the drink that I want is mocha, quantity more, and what do I want? Milk, right? So you're able to, what you're able to do is you're able to then say, well, you know, I want to build a bot, and I want to build a bot to actually take free text input. I want you to classify this, and you know, you can go back with your rule-based thing and say, all right, if somebody said X, I want you to reply that. Say Y, reply that. Or if you didn't give me enough information, I should ask you, hey, would you like me to book a ticket for tomorrow or when, kind of thing. So yeah, hopefully this has given you a bit of insight on how you could do Core ML beyond the simple, hey, here's an inception model, go classify banana versus like an apple, which is what everyone, that was the first use case for that. Convolutional nets,
Hot dog.
Oh, hot dog. Hot dog or not hot dog, that's the one. And you know, explore how you can actually manipulate tensors to do the things that you wanted to do. So like, you know, this, I mean, technically the LSTM is also very good for speech recognition. So anything that's sequential based, you can use the LSTM for. So speech recognition, we've done it with handwriting recognition as well. We've done it with, yeah, we've done speech as well. But yeah, lots of different things. I think you can do accelerometer data. So given, you know, what the gyroscope and the accelerometer is doing, you can classify if someone's walking, running, you know, whatever. So there's a few ideas on how you can do it. Any questions, thoughts, comments, queries? Oh yeah, one more thing. I am writing a Core ML book, so if anyone has any ideas or would like to know, or would like to, have, mentioned, I would appreciate feedback. It's a very weird space because I don't really know what to write, because I could write it very machine learning heavy and then everyone go, but this is an iOS Core ML book. Or I could write very much Core ML stuff, then I wouldn't really have much machine learning to write. So I kind of need to balance that out. All right, questions? Yep.
Yeah, so segue into that. So apologies if you've already covered this, but a couple this is doubled up in terms of machine learning and model learning. So how do you like you touched on it, you press the button and it trains it?
Yep.
Did you cover training and how you train a model and make use of it? Is that a bit useful to
let me see. Do I have? So let me go back to the keynote. So what's really interesting is that this code here, it's a snippet from the training code. So in machine learning, the only difference between training and inference is that in inference, you don't do what's called the backpropagation, which is the error correction, right? So in a nutshell, what backpropagation does is it says, all right, I'm going to give you these weights. I want you to predict something. And then the algorithm will predict something, and it says, all right, your accuracy is 0.78, whatever your cost function is going to be. Given a cost function, and it has to be a differentiable equation, you can, using the chain rule, backpropagate using calculus the gradients. And because you have the gradients, and the gradients will point in a certain direction. Imagine if it's a topology map. It will point to a certain direction that says you need to walk in this direction to go down the hill. And the further down you get to that hill, the better your accuracy becomes. So I'm sorry I didn't really talk much about training, but if anyone's interested, I probably could talk again some other time about actual training a model. I think the guys at MLAI may also be doing that as well, so there might be a bit of overlap there. But yeah, pretty much in a nutshell, this is pretty much mostly training, and then in most frameworks, all you really have to do is in Keras, call the command model.fit with your data, and in PyTorch it'd be something about backprop or something like that. Yep.
Okay, so after bewildering us for half an hour.
Sorry.
Where
in a good way. In a good way.
Yeah, in a good way. Yeah, in a really good way.
That's coming from Oliver.
Where is the best place to start if you're interested in learning more about machine learning and actually because you talk about gradient descent models,
yep,
differential equations, and all the rest, and some of us, including myself, know the words but
have not touched it in a long time
and haven't done real math in a very long time. But beyond basic vector mathematics or something, crap is good. Yeah, where do you start if you have an interest in learning actually what's going on when you're training, or you can follow tutorials and you're like, oh yeah, okay, you do this, and there's all these existing models and you can apply them.
Yep.
But it's still to me whenever I hear people talk about machine learning and stuff, it just seems like this impenetrable pile of jargon and mathematics and stuff.
Yes.
Right.
Don't worry, I feel the same as well. Most of the time I go to the conferences and they pull out here's the KL divergence and blah, 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 and all these math things. You just, you lose it. And to be frank, I think most machine learning practitioners are also the same. We try to hide behind a lot of math, but a lot of times they're like, I have no idea what this guy was on about. And then you usually have to sit there and read the paper 6 times, and then you go, nah, I still don't get it, kind of thing. Then you send an email, and then you say, hey, give me your data and your code. I mean, to be frank, that's what it is. Machine learning is still very much voodoo magic. A lot of the times you do, we did this, and I had no idea whether it was going to work. Unlike programming, software engineering, when you go put XYZ code, you're going to build a bridge. You're going to build something. In machine learning, you have no idea if what you're putting together is going to get you something. The only way to know is just to do it. And there are no real hard and fast rules why things work. And if it works, you just document it and write a paper and say, I did this and it worked. So this field is extremely new, very raw. There's not much discipline, and people have been railing about it and saying, oh, how can you do that when you're putting it into a car that's driving itself? How do you know it's going to work? And we just go, it kind of works. Yeah, no one died yet. And so.
Well, they talk about the alignment problem in AI.
Yes.
Of
Correct. So I think, I mean, it's very new, it's very interesting, not really ready for mission critical stuff. It's more like, hey, look, I have a dog face, or I'm vomiting rainbows kind of thing. You put it into those kind of apps and, you know, people have fun with it. Yep.
Can you speak a little bit about why we should be maybe doing any of the, caring about having the model on the device versus doing all that stuff in the cloud and just using an API to go, look, I've got some data,
yep.
Please give me the inference.
Yep. At the moment, not really. At the moment, that's probably the best way to do it. But going forward, I mean, the holy grail is robotics, right? Everyone's a robot. Everyone wants to follow you around, do stuff for you. And for that, we have to make robust AI, right? So you can't be continuously tethered to the cloud because, you know, if you took your robot out to say...
You don't want your Tesla to be reliant on trying your 4G when it's making a decision about whether or not to drive through.
I get that.
Yeah.
But as an app developer, I was trying to argue we should do it. The core ML.
The people API was broken today, so we just crashed everywhere.
Miles, it's when REA just drives you to the house that you need to buy.
Yeah. Well, I mean, the cloud providers aren't doing it pro bono, right? You pay money for them to do stuff. Like, you know, every time you give it an utterance and it does this, they charge you maybe 0.005 cents. But, you know, if you have an app that completely like explodes in the market and, you know, you want to reap the rewards of that, but you can't because now you're paying so much cloud, you know, compute fees, this is probably when it's really going to matter, right? Where you're running it on device and you don't have to rely on anybody. Because I hear that's the big problem with a lot of, you know, indie devs. Back in the days when, you know, we were able to sell an app on the App Store and profit from that, it was great, but then you had to keep supporting it, and you had to run a back end, and then your back end costs money, and then you go, well, it's not really worth it anymore. Sorry, guys, I'm going to shut this thing all down. The more we are moved away from the cloud, the more we actually can do compute on device, the better it is for, I think, experience for our customers and also longevity of our applications. Because I think that, I mean, cloud is great, but cloud is also such a massive drain on indie devs, right? Because you have to factor it in. And then once you've sold your app, unless you have ads, which is a really bad experience, you're not going to be able to continuously, you know, pay for that. So, you know, it depends on your business model. Some people might like it, some people might not. I mean, if you work for maybe REA, then sure, do the cloud because they've got tons of money, right?
I think the other point, when you had a slide up at the beginning about like why CocoaHeads or why the edge versus the core, and as you know, privacy is a big one, right? Like
correct.
Every time you're sending, like if I take a photo and I'm Instagram, I'm taking a photo and it sends it to the cloud and it classifies it as, you know, a cat or whatever it is, you're giving that information to someone, right? You're giving semantic information, right? Like at the moment, I mean, obviously people don't mind sharing their pictures of whatever to Instagram and Facebook, but you know, if you actually cared more about your privacy, it's like, well, should I really be sharing all of that data about my life with some third party who's going to potentially apply machine learning techniques to it all to figure out actually what I'm looking at all the time? At the moment, it's relying on the human to go, you know, hashtag kitty cat. But if it can just go, well, we don't care what the human says, we're just going to classify it based on our ML models.
Actually, that's a really good point as well. So if you look into detail with a lot of the ML models, ML services by the cloud providers, they are run on public instances because it's just too expensive for them to actually do anything like special with them. So if you're in a sector that has high regulation, so like healthcare, finance, or, you know, government, it's very unlikely that you can actually use any ML models for that because, you know, the cloud providers will not sign off any BAAs or whatever else around it. So it makes a whole lot of sense to do this because actually one of the reasons why we did this was that we wanted to build our own models that we can run on device because we're in the healthcare space. And also because we have the same models, they also can be packaged up into a Docker image and deployed on Metal, right? On whatever internal servers that, you know, say the government has or a bank may have. Because there is that, you know, information privacy sensitivity that comes with dealing with high regulatory, you know, industries.
Just to clarify, the reason you had that sort of web interface and everything to do the training, I mean, besides the fact that you're sending the training and doing the training in the cloud, part of the reason you want to do that is because you need to be able to sort of code gen
Correct. Yeah. So, I mean, like so.
If you didn't do that, you'd essentially just have to.
Yeah. Every model you
have to either spit out the code as just template, copy, paste this into your app,
yep.
or you know, sort of do some. Just tell the user or the client here, you know, these are the parameters you need.
Oh, sorry, I'm just realized I'm in Tether. So, no, exactly right. The only reason why we did that was that we wanted an automated process, right? Because otherwise, I mean, yeah, you can do this whole machine learning modeling. You say, all right, how many intents do you have? You have 3 of that. All right, I'm just going to modify my Objective-C or Swift code for 3, and I'm going to have a, you know, vector size of 300. I'm going to modify that. But if you do this, you never really have to touch it again because, all right, I didn't mention this in the talk, but in machine learning, what's really interesting is there are only 3 components, right? You have your model architecture, which usually doesn't change because once you find one and it works, you like leave it as a side. You have your data, which is really important, and your cost function, right? Your cost function determines how accurate your model has trained or not. And usually also you don't change that. So the only variable that you change is that data, and that data is, you know, what do I have in my sentences here? How many of them do I have? What do I tag them to be? And these are metadata, pieces of metadata that if you can capture that at this training time and apply it to your inference, then your core ML model is sweet. You don't have to like go, oh, what is the 6th neuron telling me about this particular thing?
Okay, so you're kind of saying like in core ML world, or you once you set up those intents, for example, you
yep.
can't, if you were doing this on your device,
yep.
Or just on your own machine, you
yep.
couldn't really change. You can't change the intent set without retraining.
Yeah, exactly. Because the core, so the Keras will actually spit out. So in Keras, if I go back here, so what happens is that once you train Keras to do this and you test it and it really works very well, you save the model as a H5 file. And that H5 file is what's put into Core ML to generate the, this convert call in Python generates the ML model file. It does that blindly. It doesn't know what it is. It's just taking, it says, I'm going to take in none 300. I'm going to give you like 6, and 6 is the output. But the problem is you don't know what 6 is. And I said the order is really important. 6 could be coffee, cereal, something, 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 right? So if you capture that information at that start there and you put it in, you bypass the whole static compile of Core ML, in a sense. That's why we go back into templating world.
I think Oliver has a lot to learn.
Yeah.
We've got one more question at the back and we
So you mentioned the data there, like how much data, like that example there for the coffee intent, like how many sentences or whatever, how much data do you actually do that?
This one had 48 sentences, but it varies. Again, the only way to know is to do it. That's really the mantra in machine learning. The reason why we're able to get 48 to work is we used a pre-trained word vector, fast text. The one that I was talking about, man to king, woman is to queen, because it's already captured a lot of semantic information about the world. So by it knowing a lot of the semantic information, it's able to make good guesses. So I don't think I mentioned any mocha in my training set. But because it sees the word mocha and it's very close in geometric distance to say the word coffee, it goes, well, it's most likely going to be a drink, so I'm just going to tag it as a drink. And this is the real power of these models, is that you don't necessarily have to give it every example. It should still be able to work on some things that it's never seen before just by the proximity of the words. And also, what's really interesting, we've done some really interesting experiments. We've done this in English. And then we took that and transplanted it with Chinese word vectors. And it actually works in Chinese. So you train it in one language, and then you're like, oh, I'm going to try a different word vector in Chinese, and it just spits out the correct answers. So we thought it was a bit freaky and kind of cool, but you know, your mileage may vary depending on what kind of like, you know, data sets you have and the topics.
So one of the, I think that's one of the key points you're making there is that a lot of the power that people are getting from machine learning systems now,
yep.
and things like TensorFlow and Keras and Core ML, is that academics have gone and done the hard yards and
yep.
built things like ImageVec and WordVec and stuff
yep.
like that already that give you that sort of base brain.
Yep.
And you're just tweaking it.
Correct, yeah. Yeah, so you're absolutely right. So in machine learning, well, in statistics, we call that an a priori. So in Bayesian world, the researchers have given it a lot of understanding about what the world is. All we're doing is saying, all right, I want you to take that understanding, I want you to tweak it particularly for my use case. And it's able to do that.
Awesome.
Cool.
Thank you, Han.
Thanks guys.
I think everything I know about machine learning is from your presentation from last year and from this one.
Oh, great.
Thank you very much. All right, that was excellent. We've done really well for time considering our first attempt. A few people looked at their watch. That's good. That means you weren't watching. I'm not sure where my thing's gone. I've just got 2 slides just to sort of tell you what's next. Very simple. Our next event is the Hack Night on February 21. That's not next Wednesday, the Wednesday after. It's at Anchonex on Flinders Street. The instructions on how to get there are a little bit more complex than just Flinders Street, but it's all on the meetup page. Really looking forward to that. I think a handful of us will be there ready to chat. Hon, I might invite you specifically in case anyone wants to sort of roll up with Emma. Maybe Oliver can turn up as well.
It's on Wednesday.
All right. So that's
next to it.
That's the you're really close as well.
Yeah.
Our next meetup is back here on the 8th of March. It's exactly 4 weeks from today because February, and not a leap year. Thanks so much for coming. If you can just pack, if you've got a candle bottle next to you, just put it in the bin on the way out. There's no particular rush to leave in the next 10 or 15 minutes, but I'll be packing up and just clean up on your way out. Thanks so much for coming. We'll see you next month.
Jesse.
Also, before the next meetup, yes, the first, it's Friday the
will be
2nd?
March 2nd.
March 2nd is NS Breakfast again. That will be up on Meetup as well and mentioned on Twitter.
Yep.
Yeah, thanks.
I got some more stickers as well. I got a few more stickers.
You mean?
Hey Jesse, I love all the changes.
Thank you.
All of them.
I'm really happy with the fact that we all came up with them together as a group. So everyone's like, we thought of like shortening the night. And everyone's like, yeah, that makes total sense.
Yeah.
Do you have anyone who talks about the... Hey, how's it going? Sorry, I didn't say hi. Hey, do you have anyone who talks about HomeKit? Like maybe creating like a HomeKit with the Arduino? With Arduino? I don't know. I'm asking. Yeah, I'm thinking about starting experimenting with like doing a side project on my own with that. But I was wondering if anyone had the knowledge about that.
Oh, really?
Tops.
So something with the HomeKit and Arduino. So yeah, like.
I was looking into that. It's like an open source.
Yeah, I wanted that.
It could be,
to do
yeah.
something like that.
Well, yeah, I don't have any first-hand knowledge. Are you asking me like for something like that? No, you want to look into it as a presentation?
No, I want to have a look, but I wonder if anyone knew about it.
Speak to Luke.
I don't know, relax. Again, I have no idea what that's that one right now.
Okay.
You want me to run with the machine?
Okay.
It's like, more than else,
I'm not sure about that specific case, but yeah, he's played all those devices. And I'd be really
So it will be the Raspberry Pi. It will be the main one handling the communication, and then you have the Arduino connected to the Raspberry Pi.
I mean, you have to like, essentially, you have to say, it's essentially an NS array that we really want, and then you have to say, in my NS array, I want you to use pretty flexible speed. So let's say if I have 300, if I have 5 items of 300, so I would expect an NS array of 50.
whatever communication you have from the Arduino
I forgot to mention that. Would probably have 5 objects of 300 would be 1500, and then
Yeah. So you can get your Raspberry Pi connected to the Wi-Fi on your house, and then control the Arduino from that.
Raspberry Pi can also do a lot of
yeah, so you need to mix up off the web. I don't like doing that. It's like I use this.
The Arduino.
The Arduino has a microcontroller, and the Raspberry Pi can do similar things.
All right. So you're saying you don't need the Arduino necessarily.
Not necessarily. Like you could probably get a proof of concept going just in Raspberry Pi.
No, well, I mean, when it goes through, no, you can't really.
I would like to.
It's a black box. It goes.
I recommend it.
In and out. Yeah. So most likely your concept.
Yeah.
I've been playing.